the webinar. I'd like to do a quick test. If you can hear me, please send a quick message in the questions box, just letting me know that you can hear what I'm saying. Again, if you can hear me, please just send a quick message. We can hear you. Got it. Great. Thank you, guys. Okay. It is June 22nd, 2011. Welcome to the Unitronics webinar series. We will be talking today about GPRS. Again, thank you for attending. We will continue to host these files on our website, www.unitronics.com/webinars with an S. Again, if you have any questions or recommendations or comments or anything, please send an email to support@unitronics.com with the subject webinars, and we would be very happy to hear from you. Again, we're trying to take as many suggestions as we can for new material. Okay, so let's get started with today. We will be using our Infora modem that we supply. I'll pull up the spec sheet here. You can see this is the GSM 41J modem kit. The modem is an Infora GSM 1308. It is a GSM modem. It requires a SIM card. Today we'll be working with this and a V570, and I have a SIM card from AT&T that's activated with GPRS and SMS. So we'll be working again with the GPRS portion of this. So let's take a quick look at the spec sheet for the modem here. We'll see everything it comes with. First off is the modem itself. Second, we have the antenna. We have the communication cable. This resembles the MJ1022CS25 we used to program the controllers, except this is an MJ10-22-CS72. The difference is the pinout of the connector. Uses the same standard 4-conductor RJ11 we have. And it comes with a power connector. It's not a power adapter. It's a 24-volt modem. You still need to supply 24 volts to it, but it comes with a connector. And in addition, we have the programming cable for the modem. So this is a serial modem. We do need to dedicate one of our COM ports to communication for connecting over the GPRS to the internet or sending text messages or anything we're going to do with this modem. Okay. So that being said, we can look through the spec sheet for a picture of the modem. We see that we have an a SIM card slot here. Again, GSM technology requires a SIM card. We have an antenna port. The antenna, it comes with a 6-foot cable about. You can provide longer ones. They're standard connectors. Okay. So let's talk about GPRS. GPRS is a wireless internet connection. We can use GPRS to connect our PLC to the wireless internet and connect to any server that's set up for the type of communication we're going to do. What is this useful for? Well, first off, if we want to set the controller up to access it from remote access it, we can access it with VisiLogic, with remote operate or remote access. We can use our data export software and remotely download data table files. We can use our SD card explorer, really anything that supports Ethernet connection. Again, this is a wireless internet connection. We can also connect from the PLC to other devices. This can be useful again for everything we mentioned, plus sending email, for instance, or maybe we're doing Modbus, or maybe we're using our data export. So again, we're adding a wireless internet connection capability to our PLC. If we want to talk about GPRS specifically for a minute, we can consider an internet cloud in the middle of our communication. What this means is, as far as the device knows, it should be considered a wired internet connection. Now, that's not necessarily true with cellular technology. There are firewalls that we have to deal with, and there are specific services we have to ask for enabled from cellular communication companies. We're going to look at an example of a dynamic APN. Again, an APN is a server that we're going to connect to. This is part of the configuration parameters we'll see. What I have is an example of a dynamic APN, or a dynamic IP address, and we have an APN with the username and login to gain a static IP address. Now, what are the differences here? If we're going to communicate from the PLC to another device, we're not concerned with being able to address it from the internet. There's a firewall in place generally, and in this case it doesn't matter because we're going to connect from the PLC to some other device. If some other device is our home network, we should assume that we have the capability of opening a port and leaving it open for communication for us. Now, if we want to connect to the PLC, we need to have a publicly addressable port, and it would be nice to have a static IP address to go along with that. So these are services that we need to enable with our service provider. And what it means is that I can open a port, for instance, port 20257, and I can connect to the controller. Now with a dynamic IP address, this is not always the case. Again, we need to make sure we have a publicly addressable port. So we'll explain this again in a minute. But in general, these are our two options. We're going to connect to a device, or we're going to have a device connect to the PLC. Again, in either case, the communication pathway needs to be accessible. Okay, so let's take a look at our first application we have. This is my static GPRS application. It's set up with a bunch of nice functions, and this will be available after the webinar on the website. You can see on the HMI we have the ability to start calls and to put the controller in listen mode and to register, re-register with the network. So we'll talk about these in a minute. We also see that we have some information here. Let me make this larger. Whether the modem has initialized correctly or not, the quality of the signal we have, and the status of the registration and the calls, as well as the IP address. So these are the pieces of information, the feedback that we'll get from our system. Let's take a look at our application. If we're familiar with any of our communication protocols, the beginning of this should look very familiar. We have our system bit 2, which is our power-up bit, and we have a PLC name. In this case, we've called the PLC V570. Again, I'm working with a V570 on my desk. The next item we see is system bit 2 followed by COM initialization. Again, we're using a serial port here, so I want to make sure I enable communication on COM 1 with a baud rate of 9600. And what's new here, as we should see it below, is modem settings. Under modem type, we can see previous versions we've supported for CDMA, PSTN would be landline, and GSM. The current modem we're supporting in the US is the Infora. We see all the other modems we have available here. As long as we select Infora, we should be okay. Okay. Now, before we go further into the application, I'd like to talk about preparing the modem specifically. If we go to Connection and Modem Services, we'll see the options we have for preparing our modem. Now, before we can use it, we need to program it to know if the modem is talking to, so the modem knows if it's talking to the PC or the PLC. Again, we have selectable PSTN, which would be our landlines, GSM, what we're going to use, or TAPI, which is a built-in landline modem, but we're not worried about it. So again, I'm going to select the Infora. I'm going to select the baud rate of 9600. I'm going to program this with COM1 of my PC. And I'm going to leave the timeout dial and the timeout reply as they are. Now, if we look below, we see the options to initialize PC side modem or to prepare PLC side modem. We're going to be using this for the PLC, so I'm going to connect my programming cable. And again, this is provided with the controller. And what I'm doing here is removing the communication cable from the modem and connecting the programming cable to the modem. And they're now connected. I'm going to select Prepare PLC Side Modem, and notice the options we have now. And I'm going to select Initialize Modem. What we see below here is the status of the initialization. We should see that everything comes out okay. Now, one thing I didn't mention, and you can't see at home, is I have placed my SIM card in this modem. I've placed my SIM card on, I've connected my antenna, and I've powered it up. And what we'll see is that there is a single LED on the front of the modem. If it's flashing green, it is trying to register to the network. When we have a solid green light, the modem has registered to the network. Now we need to register the modem to the network so it can check the signal quality when it's preparing here. So again, in order to do this, we need to have a SIM card with an enabled SIM card with the services enabled. It needs to be in the modem. We need to have the antenna connected, the modem powered up, and that green light needs to be solid. It needs to be registered on the network. And we see here our last comment was the modem input and 4 OK. So we have properly prepared this modem. I'm going to close here and hit OK. And I'm just going to take a second and reconnect my communication cable to the modem. Okay, so what you couldn't see there is I just unplugged the programming cable and connected the communication cable. So our modem is now good to use. Okay, so back to our application. We've properly initialized our modem. What we should see now when we power up the unit is that our COM1 should try and communicate to the modem. When we have initialized our modem, our system bit 80 should go high. So let's take a look at the relevant system bits for GPRS. I'm sorry, I'm bringing up the wrong one here. Let's look at operands and system bits. I'm sorry again, I pressed 180 instead of 80. So what we'll see here is that each COM port has a system bit associated with it, whether the modem has initialized or failed. If we go online over serial, we can check this value. We'll see that we have this application loaded already, so our system bit 80 has gone high because we have initialized it. Now it's important to note that there's an initialization for succeeding and a bit for failing. If we just had one, we couldn't tell if it started, what would happen. When we restart the power to the controller or we reinitialize it, they're both 0. So we're going to wait for one of these to go high. And upon system bit 80 going high, we're going to perform our GPRS config and our GPRS registration. So let's take a look at these function blocks. Our GPRS configuration is pretty straightforward. We can give it a name. Again, if we wanted to have 3 separate GPRS configurations, we could do that because it's possible to have 3 separate serial ports on the 570. Information we're giving it is port 1. We're going to use COM1. Again, it's important to note that system bit 80 pertains to COM1, so we need to select port 1 for this GPRS configuration. We have a status message and a call status, and we can look in our help file for the relevant values here. Okay, once we've configured our GPRS, we can run GPRS registration. Now this is where we need to enter the information that will be provided to us from our service provider. Let's take a look here. We see that there's an APN server. In some cases we need to provide a dial number, but not usually. There's a username and there's a password. Okay. And again, this information is going to come from the service provider. What I have is my specific username, password, an APN server that's given to me for my static IP address with the communication options that I've asked for. So again, these options are enabled from AT&T. You can use certainly other GSM service providers, but I happen to have an AT&T card. Okay. So in the next step, we'll see the positive transition of MB1. What was MB1? Again, if we want to find some bit, we can hit search. And we know we're in net 4, so let's look in the previous one. It was the registration bit from the GPRS registration. So when we've successfully registered, we're now going to perform a task of taking our IP address and storing it as an ASCII into MI20. Now this is nice because if we want to display it on the HMI, as we do here, or we want to send it in an email, or we want to send it in a text message, we can do that. We have access to that. Okay. And the next thing we're going to do as well is run our GPRS run function block. Now, notice that this is tied to a normally open contact of system bit 80. So if we've initialized, we want to continually scan this GPRS run function block. Okay, so these are the functions that we need to do in order to enable GPRS. When we start the PLC, again, we're going to run our COM init. When registration is, when initialization is successful, we're going to run GPRS config, GPRS register, and then we can run GPRS run. Now the following function blocks are the options we have to either contact a device or be contacted by a device. So basically that means we can put the controller in listen mode, or we can call to an IP address. Let's take a look at where we can find these functions. And again, we have start call and end call. You can compare these to being the master if you're used to using Ethernet and you want to make a socket connection or close a socket. And we have a listen to remote device and stop listening to remote device. What we can do with these is put the controller in listen mode, and we can communicate to it from the outside world. Let's take a look at the start call function block. We have two parameters here. One is a port and one is an IP address. And if you're familiar with Ethernet, these should seem very familiar to you. What we can do with these is connect to a remote device. What we'll see in the next example is we're going to connect to an email server and we're going to send an email. You can also use this if you were using Modbus, if you were using data export with the Ethernet option enabled. Anytime you need to connect to a device, this is the function block you're going to use. And also we have the end call. Now what we're going to look at next is the GPRS listen function block. And take a look at the parameters here. Remember that the IP address was assigned to us, so we don't have the ability to enter an IP address here. We're just going to select the port we want to listen on. In this case, it's 20257. Okay. Again, these are single scan transitional elements. You notice that they're both set up the same. We have a positive transition, and if our registration status is high, then we can run these function blocks. Same thing is true with the end and stop listening. And the last function block we can look at is our check signal quality. If we want to look at system integer 185. We note that it is the GSM signal quality for COM1. So let's go online here. We'll take a look. The value is currently 25. Now this system integer has a range of 0 to 31. I should say that it has a range of -1 to 31. If we see a -1, it denotes that we have a problem and there's no signal, or more than that, there's a problem with communication. The threshold here is 12. So Infora has stated in their spec that if the signal quality is less than 12, you need to reposition your antenna to gain better signal quality. What are factors involved here? Well, maybe interference, maybe distance from a cell tower. This is a cellular network, so everything that you expect with your cell phone should pertain to our signal quality here. Okay, so let's take a look at the application running now. I'm going to bring up the HMI. And again, we notice that our registration status, this is our bit from the registration block, is 1. Our call status is 0 because we're not currently doing anything. Our IP address, and again, this is the static IP address. So what that means is that this IP address is always going to be the same. If my controller is on and it's in listen mode, if I know the port that we specified, I can connect to it with this IP address. Okay, we have our status message. Registration complete successfully. This is from the status messages, and it's just a binary, it's a text by pointer. Again, where does that information come from? Status messages in the help file. And on the right, we'll notice that we have our initialization or initialization failed. This is our system bit 80 or 81. And we have our connection bit. Okay. Again, we can check quality. I should mention that the quality, system integer 185, this is updated when you initialize and for that first initial startup, or when you run the check quality function block that we saw in the previous ladder. Now what we're going to do in this example is put the controller in listen mode. So these buttons all pertain to the HMI, to the ladder. I'm going to go ahead and select listen. Modem replay error. Okay, sorry for that. I think we were playing with things. What I'm going to do here is just cycle the power, and we'll watch the system start up again. So it generally takes about 45 seconds for the system to start up and for the modem to register. So we can see that here. Notice that our initialization and initialization fail have both gone back to 0. Our status message is no message. Okay, registration in progress. Our quality has now gone to 25, which is a good sign. Okay, and our registration has been completed successfully. I'm going to hit listen again. This time we have success, which is good. So our controller is in listen mode. Just like a remote slave device over Ethernet, we can connect to it on the IP address and the port that we know. In this case, the IP address is the static IP address. The port is 20257. Remember, that was from the listen function block. I'm going to close this. I'm going to go offline. Notice that we've been connected, over serial. I'm going to go to communication NOS. And I'm going to change our connection type from serial to TCP/IP call. And we're going to communicate and contact this controller over the internet. So I have set up in my favorites already the IP address, protocol is TCP, port is 20257, and the PLC name is V570. Again, it's very important to note that this is case sensitive, so that's a capital V there. I'm going to hit OK. And one thing that's good to do over these wireless communications, or any time that you don't have really local, is you can bump up the timeout to make sure that we can maintain connection. So I'm going to hit the check PLC button. I'll just give it one more second. Okay, and now we've returned our information. It's a V570, the OS version. Great. So we have communication with this controller over the wireless internet. I'm going to hit exit here, and we're going to do a quick example. I've set up on the HMI. If you want to take a look real quick. Memory integer 10 as a keypad entry variable. So we're going to go online, and we're going to watch it here. I'm going to edit it on the HMI, and we'll see it update. So let's go online. Again, we're doing this over Ethernet. Give it a second to connect. Again, this is the example of the static IP address. Because we have a static IP address and a publicly addressable port, we can connect to the controller over the internet. What we'll see in the next example is the dynamic IP address with the dynamic APN server, which, by the way, if you use a AT&T cell phone, for instance, like BlackBerry, you notice it's the same APN server address and the same login information that you use for those. Generally, unless you specified, you get a different IP address every time you try to connect. So if we're in a situation where we're going to communicate from the PLC to a remote server, we don't need to specifically have a static IP address. We don't need to be able to communicate to that device. This is an example of one-way or two-way communication. Okay, so now you notice our value is 459. I'm going to go to my keypad entry, and I'll enter the value 2. And we see we've updated it here. Again, I'll just do another. I'll put in 88, and we see it should update here. Okay, so we're connecting to this controller and we're reading out the values over the wireless internet connection. Okay, and again, we've connected to the controller in this example because we have our publicly addressable port. Okay, I'm going to leave the online test here, and I'm going to open my other example we have for email and dynamic IP addresses. Okay. So give me 1 second, and let me just download this to the controller. So, what are the differences going to be in this example? Can anyone guess what we're going to do after we register to the network? Again, the goal here is to send an email from the controller. So what function blocks do we need to use this time instead of the ones we used last time? Anybody? Okay, I guess you're a quiet audience today. Let's take a look at this application. Basically what we're going to do now is communicate to a mail server. So instead of putting the controller in listen mode, we're going to use the connect function block. I'm sorry, the call function block. Let's go over this. Let's go over this application again. Again, system bit 2, power up, PLC name 570. System bit 2, common it 4 and 4. We notice the same exact settings here. Again, the baud rate of 9600, it's important. This is what we need to communicate to the controller. Positive transition of system bit 80. That was our initialization succeeded on COM1. Running our GPRS config function block, again port 1, with our status message and call status. GPRS registration, let's take a look at this. Notice now we have our default publicly accessed APN server for singular. It's wap.singular. Username wap@singulargprs.com. Password singular1. You can find all of this information plus really basically everyone's public APN servers on the internet. If you didn't know them, if you didn't have them provided for you from the service provider, which they should absolutely be able to provide for you. But there's a couple giant lists of APN servers for public access. Again, you need to be a member with a SIM card from the service provider, but these are their dynamic public APN servers. Okay. So again, we're going to connect to this, and we're going to get a dynamic IP address. It means it's going to be different every time. If we need to know the IP address that we currently have, that's where our IP to ASCII function block comes in. Again, we can't connect to the PLC in this case because we are behind a firewall on the wireless internet cloud. But we should be able to connect out from there to a device. And in this example, our mail server is going to have a static IP address. We should always expect that we can connect and communicate to a mail server. It shouldn't change. Okay. Again, positive transition of our registration bit runs our IP to ASCII. When system bit 80 is high, we're going to run our GPRS function. Now, the difference is here. We're going to perform a GPRS start call to a specific IP address with a specific port. This one's configured to connect to my mail server. Okay. We also have an end call function block. And if we didn't really talk about email yet, we'll just mention that system bit 345 is an email send in progress. The negative transition of the send email, that means when we're finished sending an email, is going to run the GPRS end call. But notice we've also put in parallel a button for end call. So if we've started a call, we want to disconnect, maybe we didn't send an email, we can still end the call. Okay. And again, we have our unregister. This will unregister us from the network. Now what's a little different here is we have a send email function block. So again, just like when we use Ethernet, if we were going to do this over the Ethernet card, we would make a TCP/IP socket connect to the mail server. We would perform our email function block, and then we can do a socket close. In this case, it's a start call over GPRS, and it's an end call with GPRS. So let's take a look at the email function block here. We'll just notice there's a couple parameters. Now this is the same email function block we use when we are on Ethernet, except we're going to use it over COM1. Notice that we can use all 4 of our Ethernet sockets and all 3 of our COM ports. We don't want to talk too much about the email function, but we can just say I do require authentication, and I've enabled that. We have our from field and our to field. Notice that this is MI100. We take a look at the email book. I put an indirect option here. Actually, I erased it. I put an indirect option in here. So this is going to be an email address we can type in from the HMI, and we can send an email to. I should mention these are all indirect options here. The from, display name, CC/BC, subject, and email body. Notice the email body should say email via GPRS test, hello from Unitronics webinar. One of the very nice things that we've added to this is the ability to add attachments to email. And this isn't specific for GPRS, this is specific for the email function block, so it works with Ethernet. But if you have an SD card, we can select any of the files that are on the SD card, and we can email them. Now say we're doing data logging and we're logging to the SD card in Excel file and we make a new one every day. Maybe at the end of the day we want to email the Excel file to a customer or to the main office. We can set this to automatically do that. From the parameters here I would select the Excel folder we have and I would type in the file name. Again, if it's indirect we can set it and we can select this file to email. Okay. And again, the body can be an indirect email. So maybe we want to make a new string based on alarms. Maybe we have 100 doors. We can use an indirect string to tell us what door is currently open or what boiler is currently going out of control. These indirect options make it very nice to use a function block and basically dynamically change the attributes for it, whether it's the email address or the from address or the attachments or the body here. And you can see as well we have a status message and a recipient status. Again, if we go to the help, we can see the description of both of these. Okay. One other thing to add here is that the system bit 281 lets us know when the server is online. So this is when we have connected. And if we don't have an email in progress, we're going to try and send our email. So let's take a look at this application. I'm going to go online with serial here. Well, first I'm going to reset the controller. Let's bring up the HMI and let's just watch it connect. Okay, notice initialization and fail is 0 right now. The status message is no message. What we should see is our IP address change and our status for initialization goes high. Now I'm going to ask for someone from the audience to please type in an email address, something someone can see, so I can type it in here and I can email you, and then you can receive an email. I'll just take the first one someone types in. All right, thanks, Jamie. Okay, we see our registration is completed successfully. And our new IP address, 10.189.251.163. Again, this is our dynamic APN server, so we cannot connect to this device on this IP address. But we can still connect to a remote device from this. So the first thing I'm going to do is type in the email address that was given. Oops. Okay, and again, this is our indirect email option. So we've created an ASCII string on the HMI. Now the two steps we need to perform. First, we need to start the call. When we've connected, our system bit 281 should go from 0 to 1. When it has, we can hit the send mail button, and then you'll see that will pulse our memory bit 3, and we'll send the email. And I made a mistake. Okay, there we go. So I'm going to press start call. Okay, and notice that we've connected. Our GPRS server is online. Our system bit 281 is high. I'm going to press send mail. Notice that the mail send is in progress. Okay, so we've completed our mail send. Jamie, please let me know when you receive that email. Again, this can be used in many ways. If we want to automate this again, we need to place a start call. We can use system bit 281 as an indication that we've connected. Then we could run our email. We have this on touch buttons just for example purposes. So are there any questions on this so far? No questions. Again, this is a widely used function block for when we have, for example, customers with remote locations. Maybe it's on an oil pump monitoring station, and we need to email every day's information to a mail server. Again, people have used instead of the email function block, if we want to use Modbus connection, or again the data export option. Everything we would want to use over Ethernet we can access for the most part with our GPRS option. Okay, so at this point I'm just waiting for confirmation from Jamie, but if anyone else has any questions, please let me know. These are the two examples I wanted to show with GPRS. Again, we used one example where we connected to the controller and one where we connected from the controller to a remote server. If you have any questions, please feel free to ask. If you would like these example programs, they will be available on our webinar page, which is www.unitronics.com/webinars, where you can find the rest of the webinars that we have previously done. And again, if you have any other ideas or examples or requests, please let us know. Okay, I guess that's all I have to say. I'll leave this open for you if you want to ask any questions, but thank you for coming to the webinar. Expect to see an email shortly with the next upcoming webinars. We're going to be going over the protocol function block. We will do one on strings, and we should be doing one on PID as well. So again, look in your mailbox for those emails, and they'll be in the schedule. So thank you for coming, and everyone have a nice day.